Hi all. So in the previous tutorial of linked list series, we talked about how to delete a node from a given location and insert a deleted node at the beginning of the single linked list. Now in this tutorial, we'll be talking about how to delete a node from a given location and insert the deleted node at the end of the single linked list. So let's get started. So these are the set of elements of the single linked list which we will be using in this program. So in this program also, we'll be taking a help of three helper variables. The first one is previous, which will be pointing to the previous node of the current pointer. The second one is current, which will be pointing to the current node of the single linked list. And the third one is counter, which will be counting the location of the current node. So when we traverse from the first node, that time the counter value will become 1 because we are at first location of the single linked list, and you can see previous is still pointing to null. So as counter value is 1 and the location, the node which we want to delete from third location, so that location value is not equal to the counter value, so we will be keep moving forward. And now you can see previous is pointing to the first node of the single linked list, which is 10, and current is pointing to the second node, and counter value become 2 because currently we are on second location of the uh, list. So this counter value is not equal to location value. Location value is 3 and counter value is 2. Still we are not on the right node, so we have to move one step forward. Now you can see previous is start pointing to the second node, which is 20, and uh, current node is pointing, like current reference is pointing to the node 30, and counter value become 3, which is equal to the location value. It means we have to delete this node which has data value 30. So now with the help of these previous and current reference, we'll be deleting this node 30 completely from this list. So firstly, we'll be removing the link between 20 and 30 node. So let's do that. Now you can see the link between 20 and 30 node is removed. Now, with the help of previous and current variable, we'll be removing this node completely. Like previous next will be the current next. So current is this one, and next is nothing but a 40. So when our previous reference will start pointing to the current next reference, then only this node will be completely removed. So let's do that. Now you can see the node 20, now it is start pointing to the node 40, and 30 node is still pointing to the node 40. Now we this is eligible to remove the reference between 30 and 40. So let's do that. Now you can see the node which is at third location is completely removed from this list, and now node 30 is pointing to null. So we have done with the first step. The second step is we have to insert this deleted node at the end of the single linked list. So let's do that. Now uh, the node which is currently on the last node of the single linked list, that should start pointing to the deleted node, which is 30. So let's execute that step. Now you can see the node 40, which was the last node of the single linked list, now pointing to the deleted node, and now a deleted node will become the last node of this list. So after performing these both of these steps, the final framed linked list looks like this. See, 10, 20, and 40. So if you could see in the previous or in the old linked list, so there is a node between 20 and 40. Now that is removed, and that node was inserted at the, so that node is inserted at the end of the single linked list, which is 30. Now you can see this node which we deleted from here between 20 and between 20 and 40, now that is inserted at the last. So this is a final expected list from this implementation. So, and this is a graphical representation discussion. Now let's get started with the backend implementation. So this is an implementation of previous tutorial where we talked about how to delete a node from given location and insert the deleted node at the beginning of single linked list. Now we will be reusing these set of implementation because previous tutorial implementation and this program implementation somewhere similar. So delete node from the location and display all the elements of list are the common part in both of the implementation logic. Just that the changes or the variation between both of the tutorial is this one. Previous tutorial we had implemented insert node at beginning. Now as a part of this tutorial we will be implementing insert node at end. So these are the only changes. So what I will be doing, I will be reusing these uh, implementation logic by changing the name of the class from beginning to end. And here, as we talked about, the two method implementation is same, and just that this is gonna change. So this there's only in this implementation we are assigning the root node to the deleted node. Like we are making a deleted node as a first node of the singly linked list, but that is not required in this current uh, program implementation. We have to insert at the end of the list. So let's change the method name first. So currently we are starting from root node because we have access of the linked list with the help of root. Now we have to traverse until we'll not reach to the end of the node. So what we will be doing, we'll be doing null check here. If the if the root dot next, if it is not null, then we have to keep iterating these steps which we are going to write inside the while loop. So the steps are root is equal to root dot next. Like if there is elements present next to the root, then we have to keep moving one step forward, and then we have to check the same steps again whether the current node dot next is pointing to a null or not. If it is not, then keep moving, right? Because now we need to reach to the end of the single linked list, then assign the deleted node at the end. So in this case, if the last node reference is pointing to null, so what we will be doing, will be simply doing root dot next, which is currently null. We'll be assigning that to deleted node. So last node reference will start pointing to the deleted node, and deleted node reference will be making uh, null. I mean, by default it is null only, but we'll be making it to null, and then we'll be returning root back. All right. So this is the only implementation in this. So let's go back to our client. So in client, actually, this is also a previous tutorial client where we are building the linker list and calling the insert node at beginning. So we will be reusing this so that we can reuse this um, linked list creation part. Copy, and instead of beginning, we'll rename it to end. And now you can see, sorry, it should be end. It's typo here. All right. Now till here we'll be reusing this code. From here the first line is also similar because we will be printing first, and then we'll be calling delete node from location by passing root node and the location itself, because we are trying to delete node from third location. All right. And then we'll be printing the node which we have deleted, and then we will be calling what is this, delete node from insert. Okay, then once we deleted the node, then we'll be inserting at end. So that we'll be doing with the help of uh, delete node from location and insert at end. In end we have one method called insert node at end, where we'll be passing the root node along with the deleted node, and head will remain same because we have not done any changes in the uh, starting of the list. Like we didn't touch the head part of the list, we just have done the changes in the tail of the list. So instead of sending the new head, we will be sending the previous head only, which is the node 1. Now let's run this program now. Let's verify. Yeah, so here 10, 20, 30, and 40 was the list of our elements, and we deleted the element from third location, which is 30, and it is printing that the deleted node is 30. And we have added sorry, new head is this one, as it is we haven't done any changes in the head part, so it is remain same. And then the deleted node is inserted at the end of the list, right? And the list which was there between 20 and 40, here you can see in the old list, the node between 20 and 30 is, sorry, 20 and 40 is 30, which is removed in this list in output, final output. So that become a last node of the synced linked list. So now if you want to change like location, let's say third, instead of deleting third, you can, if you want to delete the second node, you can do that, you can do that as well. Yeah, so you can see here 10, 20, 30, and 40. So deleted node. Now you are deleting from the second location. The node you have deleted from second location, that is 20. So it has deleted the node properly. It says the deleted node is 20, and the newly head is remains same. There won't be any changes. Now you can see the node between 10 and 20 is 10 and 30 is 20, so which is not like present in the final list. So it is removed from the second location, and it is added at the last of the synced linked list. So our program is working fine. So let's wrap up with this tutorial, and let's catch up in the next tutorial. Thank you.